All right, so another process we need to discuss in the division of radicals is rationalizing the denominator. In the previous example, we saw something like this, where if they were both radicals, we were to rewrite them as one fraction. And in all of those examples, if you didn't notice or didn't pay attention to it, the denominator disappeared. Like the other one we ended up with, I think it was radical 30, where everything just disappeared. Well, in this case, that doesn't work. 2 won't go into 7. So we can't use the process of dividing it as a fraction, so we have to do something else to get rid of this decimal from the denominator. So what do we do? Well, it's pretty easy. The process of rationalizing the denominator is the process of moving a radical from the denominator to the numerator. So I make note of that, because you always want to try and make note of what you're doing. What is it that they're asking me to do? They're asking me to move a radical from the denominator, which is the bottom, to the numerator, which is in the top. How do I do that? I simply multiply the radical by itself. That's exactly what I do. I multiply the radical by itself. Okay? Now, here, what we mean by that is we multiply the denominator by itself. Well, and we're going to go with a little disclaimer here. Reminder, whatever we do to the denominator, we have to do to the numerator. Okay? You must also multiply the numerator by the, that's horrible, by the radical 2. Alright, so TOO, you must multiply the radical by that as well. Alright, so let's think of that if I multiply the denominator by radical 2, because again, I can have a decimal in the numerator. I may not have a decimal in the denominator. So I got to multiply both by radical 2, radical 2. It's there. It's not a big secret. Gee, I have to remember. No, it's right in front of you. So let's take that and let's perform that. We multiply straight across. So I'm going to get 7 times 2, and I'm going to get rad 2 times 2. Well, in this process, what I want to do is I want to pay attention to the numerator and see if there are any perfect squares. 7, 2, different numbers, not the same, not a perfect square. My next progressive step is going to look exactly like it is, which is a square root of 14. 2 2's, create a perfect square. Square root of 4 is 2. Bring out a 2, not a 4. Done. That's it. All right? And then we'll go ahead, we'll do 1 or 2 more of these. I'm going to do number 3 as an example. Well, the reason I'm going to do number 3, and I like the example, is because it has coefficients out there. It doesn't say anything about doing anything with the coefficients. It just simply says multiply by the radical. So the only thing I'm concerned with is the radical. Now this has lots of stuff. My next progressive step, I'm going to leave the coefficients out there. Again, reminder, I only want to get rid of the decimal. 3 is already a whole number. I may have a whole number in the denominator. I just cannot have a whole number in the numerator. So I've got to get rid of that decimal out of the denominator. That's all I want to get rid of. So 3/4. 4 is in the top, 3 is in the bottom. You've got to pay attention. Keep those where they should go. Now I have rad 42 times rad 14. Well, again, the whole purpose of simplifying radicals is to find perfect squares and take them out. Find those whole numbers. Some of us are still not getting the concept. Pay attention to it. I'm going to factor 42. 7 times 6, right? But can I factor 6? Sure, 2 times 3. Why do I factor 7 and then factor 6? Well, because I have 14 over here, and I know 14 factors is 2 times 7. 7 times 2 times 3 times 2 times 7. It's the same thing as if I multiplied 42 times 14. And then in the bottom, do I want to factor 14 and 14 as to 7 times 2 times 7 times... No, I don't want to do that. Why? Because they're both the same number. Remember, the object in simplifying radicals is to find 2 of the same to remove 1. So I start with the numerator. Now I can simplify radicals. 2 7s create a perfect square. 7 times 7, 49. Square root of 49 is 7. Alright? I'm going to just highlight all my other perfect squares. 2 2s. Are there 2 2s? Yes, there are 2 2s. There's only 1 3. Can't do anything with it. And in the denominator, I have 2 14s. So after I've circled all those, now I can take all my perfect squares out. Mind you, I haven't done anything with this 4/3 yet. Haven't done anything with it. It has to stay. It can't disappear. I get a pull out of 7. That's a whole number now. Square root of 49 is 7. It's a whole number. I got to pull that out. So I'm going to mark that I took that out. The 2 2s create 4. Square root of 4 is 2, not 4. Stop and think. What's left? Square root of 3. The 2 14s create a perfect square. Whatever 14 times 14 is, I don't care. The square root of it is 14 because 2 of the same makes 1. Now watch what I'm going to do. I'm going to go ahead and connect these. I'm going to multiply them. Ooh, but I didn't actually multiply them. Why not? I didn't actually multiply them because I want to see if I can reduce. Hey, guess what 7 times 2 is? 14. 14 goes into itself once. 14 goes into itself once. And then now I can multiply straight across. And what is my final answer? My final answer, therefore, is going to be 4 square root of 3 over 3. Let's pick one of the ones on the other side of the page. Let's pick, let's just do number 5. I think your numbers might be a little different. You might have 8, 9, 10, because that's 7. It just got numbered differently. You know what? Let's pick 8, because 8's got the coefficients. All right? So again, 2/3 is going to stay. I'm going to go ahead and multiply both the denominator and the numerator by square root of 40. So factor 15, factor 40. The factors of 15 are 3 and 5. The factors of 40 would be 5 times 8, but let's factor 8 as 4 times 2. So 3 times 5 times 5 times 4 times 2. Same thing as if I multiplied 15 times 40. And in the bottom, 2 of the same number. Now, identify your perfect squares. So sorry for the little bit longer video, but I think it's necessary at this point. I have 2 5s. 2 5s make a perfect square, because that makes 25. Square root of 25 is 5. 3 is, are there 2 3s? No. Is there 2 4s? No, but 4 is a perfect square, so I'm going to identify that. And 2, not a perfect square. 2 40s make a perfect square. So here we go. We're well on our way. Keep the 2/3. Didn't do anything with it. Remove my perfect squares. I get to remove a 5. I get to remove a 2. Square root of 4 is 2. What stays? The 3 times the 2. The 40 comes out. And again, I'm going to connect these. I'm going to multiply them without actually multiplying them, because I want to be able to reduce. 2, 5, 2. 2 times 2 is 4. 5 times 4 is 20. Will 20 go into 40? I just combined everything together. Yeah, 20 will go into 40. 20 goes into itself once. 20 goes into 40 twice. And then I can multiply. So therefore, I get 6 in the denominator. And 1 times radical 3 times 2 is 1 rad 6. There's my answer. Work on the rest of these. If you have questions, ask. I know this stuff is tough, and you got to pay attention. You got to stop and pay attention. What is it exactly I'm doing? All right, stop and think. Some of us are still having issues with the addition and subtraction of radicals, the multiplying of radicals. Ask questions.